So thank you so much for coming to my talk today, and thank you Swift Heroes for inviting me to talk today about Swift Argument Parser and Swift Argument Parser and how it could be your friend. A little bit about myself before I get going. My name is Leo Dion. I am a Swift developer. I specialize in development in Swift. You can find me on Twitter at LeoGDion. I do Swift development on all sorts of devices, so not only iPhones, but I like to build apps for the Mac and for the watch as well as getting really deep diving into Vapor lately, which I've really enjoyed. I have been running my own company doing independent solo development and consulting and developing indie apps with my company BrightDigit.com. And I also run a podcast, which I think is up to like episode 64 on Swift development and just what it takes to build a iOS app and like the managing of the project and starting with your idea, UI design, remote teams, things like that, and all sorts of new features. So you'll definitely want to check my podcast out at empowerapps.show. So why today we're going to be specifically talking about command line tools and what it takes to build a command line tool. Stefano had a really great talk today on automation where he kind of touched on some great tools that can be built using with command line tools. And it can tend to be a lot of work, a lot of housekeeping. You have to deal with the actual process that you're going to be running. You have to deal with arguments and parsing those into the right types, execution, help text, as well as dealing with any errors. So it's a real challenge trying to parse yourself the arguments that you need for your command line application. So today we're going to build a kind of a Hello World app, but I figured I'd make a little twist on it. And instead of doing just Hello World, we're going to build an app called Hey Sap, because if you're going to build an app in Swift, you may as well call it Hey, and Sap for Swift Argument Parser. And you could check that out in the Git repo address below. So it's going to be a little bit more involved. So rather than just the simple hello world, you can pass in different salutations. You can ask for verbose. You can type in a name, and then it will give you, if you say, hey, Leo, with the salutation, ciao, and verbose, it'll give you something like this, ciao, Leo, how's your day? So a little bit more complex today than the typical hello world. So how do we go about writing this from scratch? No help, no other libraries, anything like that. It would look something like this, which quite frankly is a mess. I mean, it works, but there's all sorts of challenges that you're going to have to deal with. Specifically, you have to deal with, actually parsing some of these values and types in a Swifty manner, which would be helpful. Dealing with edge cases, making this actually a testable application that you can do unit tests on. And there's no helpful guide for users as far as helping them understand how to pass in arguments or what arguments you accept, things like that. So let's take a look at what we can do to improve this with other applications and other libraries. Here, let's look at some of the other libraries that are available when it comes to creating a command line application. So one is DocOpt, which is pretty popular throughout the developer world. DocOpt is a command line interface description language. It's available in multiple languages, so you can it's available in C++, Python, Go, and Swift. Unfortunately, it really isn't actively developed right now, but it's nice that there's something out there that is kind of useful on all sorts of languages. But it's just, from what I've seen, the Swift component just isn't actively developed right now. So the team at Carthage have developed their own called Commandant. And this I've seen actually used quite a bit throughout throughout the community. And it seems pretty robust, and obviously it's going to be used by the Carthage team itself for the Carthage command line tool. So that's one alternative you have. Now, if you're building a server-side application in Swift, the Vapor team has a console kit, which I'd actually recommend if you already have a server-side app and you need to do something like some sort of batch process on your server, or you need to update a database, things like that. This is where console kit is really useful. I've been using it on one of my side projects that are built in Vapor as well, and it works out really well, specifically because you can share a lot of that configuration that you use with console kit. So then the question is, why should you then use Swift Argument Parser? So there's a few reasons. Here's an example now where we're doing essentially the same thing that we did in that large mess of code before, but using what Swift Argument Parser provides for us. In this case, we just need to implement the parsable command. As you can see, there's a few property wrappers to specify what kind of type it is. And then all we have to do is specify our code that we actually run within the run method that is located here. And then at the end, when our main.swift, we just have to say the name of the type, in this case, hey, and then call main, and then it'll just run our command line application pretty easily. So then Swift Argument Parser really provides a lot of robust tools and things that we can use to make it easy to maintain an app like this, because it provides typed commands, arguments, and options and flags. So rather than having to actually parse the value and then cast it or call an initializer, it does that all for us, and it does it in an elegant way. It has a Swifty API to take advantage of the actual Swift language. And then it has built-in support for things like help and shell completion as well. It uses a lot of the recent language features that we've seen in Swift 2 and Swift 1 and Swift 3 that make it an elegant design. So for instance, if you use Codable, which was introduced back in Swift 4, I feel like it doesn't use Codable, but it has a lot of the same principles for being able to decode and encode, specifically decode arguments and different types out of what you pass through the command line. And it also uses property wrappers quite a bit. So if you've been doing a lot of Swift UI, and we've been talking about property wrappers today quite a bit, it actually uses property wrappers in a really clean, elegant way for building a really robust command line tool. So the first thing you're going to need to do is understand Swift Package Manager, because this is going to be your main tool for building your command line app. As far as Swift Package Manager, you can obviously create one in Xcode pretty easily, but you can also do it through the command line as well. So if you're in the command line, just simply run Swift package init and specify the type to be executable, and it will go ahead and create an executable Swift package for you. And what that means is you'll have a folder structure similar to this. We won't have a lot of the extra source files, so we'll just have a main.swift, but it'll automatically build for us a test target, which is what it's called, as well as a command line under sources, in this case, hey, with a main.swift. So if we want to just build hello world using Swift Package Manager, all we'd have to do is then in our main.swift file, simply have print hello world, and it'll run that code right away. If we want to add Swift Argument Parser, we're going to need to add a couple of dependencies in our package.swift. In this case, we're going to be adding the dependencies for the Swift Argument Parser repo, and we're going to need to add the dependency of the product under our target, which is our command line tool, in this case, hey. The way the dependency works in the packages is you just have the GitHub repo URL and then whatever the latest tag that you want to pull. And then under dependencies, you just need to specify the product name as well as the package, which is basically the last part of the repo URL. So this will give you Swift Package Manager automatically, and it will automatically resolve those repos and build out that package. So let's go ahead and build our first command. In this case, we're going to just have a simple command that prints out hello world, but within the framework that Swift argument parser has. In this case, all we have to do is we have to just say print hello world, and we're good to go. So let's deep dive into the different components, specifically arguments, options, flags, and subcommands. So as far as arguments are just the simple little strings that are parsed out within your command line parameters. And then we have options, which are just basically key value pairs. You can use a dash or double dash and then separate your key and value with a space or equal sign. And then you have flags, which are basically kind of like options, but they don't have a value attached and can only be parsed into booleans or integers as far as like a count. But typically they're kind of just used for booleans. And then we'll have subcommands, which we'll get into last, which is about the setting up like inner commands within a command. You've seen this with Git, and you'll see this with Swift as well, the Swift command. So let's get started with having arguments. How do we add arguments to our command line tool using Swift argument parser? So here we've added a new argument for the name of what we want to say hello to. And we say that the type, that we specify the type here as string. We have a default value of sap, and then we have a property wrapper to signify that this is an argument. And in our run, all we have to do is just say print. We say hey, and then the name. And so if we ran this with hey Leo, which is my name, it'll just say hey Leo, pretty easy. If we don't specify an argument, then we end up with just hey sap, because it'll just use the default variable, the default value. So we can remove the default value, and by doing this, it will actually give feedback to the user saying that they need to specify an actual name. So here's what it'd look like if you didn't specify a name. It says expected argument name. Pretty easy to understand, at least some decent feedback for your user. So that's really nice in case you actually have a required argument that you need. Now let's talk about flags. Like I said, flags are really simple. They can only be taken in as integers as far as counting each flag, but they can also be used as booleans as well. So here's an example. Here's what we had before with just one argument. Now we're going to add a boolean flag for verbose. So here we add a default value of false. We call it a flag. And then what we're going to do here is if you set verbose, it doesn't end the line with a exclamation mark, but in fact it prints out how's your day afterwards. So let's see how this would actually work. So here's what we had before with hey Leo. It just prints out hey Leo. If we add verbose, it says, hey Leo, how's your day? Pretty easy and simple to understand. We could also set up short flags if we want to. To do that, the flag property wrapper also takes in a parameter called name, which has a series of, it has an enumeration with a series of properties. It's actually not an enumeration, I shouldn't say that. It's more like a flag set, essentially. So you can say, in this case, that you take both the short, which is -v, the first character of your flag, as well as long, which is the full name of the property. We could say just short. We could say custom long and then specify a string. We could say custom short and specify a string. We could also add them together because it would be a set. In this case, we have custom short v and then long as well. Or we could just say long, which is the default. So what's really nice here is Swift argument parser also gives you a lot of flexibility, but also in a way where it's like strongly typed and using a lot of the niceties of Swift in order to do that. So here's again our example with flag and how to set that up with verbose. We could also do inversions. In this case, we could say that we want to enable verbose and disable verbose, which automatically interprets it as a true and false within that property. We could also do no, so like no verbose and verbose by using the prefixed no enumeration as well. So now that we touched upon flags, let's talk about options, which, like I said, is more like a key value pair. So here's our code that we've already had. We have a flag set up, and we have our argument for our name. let's add a flag let's add an option for our salutation, because we want to be able to say different things instead of just hey. We want to say hello or ciao, whatever we want. So here's how we do that. We have a new option, in this case, salutation, with a default value, hey. And then we're just going to take the raw value of that enumeration and capitalize the first letter within that salutation and print that out. So if we ran this, oh, by the way, here's our salutation enumeration. As you can see, there's a variety of different choices we have here. It needs to have a raw value in order to be interpreted, but it also needs to implement the expressible by argument protocol as well, which is supplied to us from Swift Argument Parser. So it'll automatically take the string from your command line and parse it out into an enumeration for us. So before we had just simply hey Leo. If we want to change the salutation, in this case we want it to say hello world, we say hey world -- salutation equals hello, and it'll automatically be parsed. We can combine all these further and say hey Maximiliano salutation buongiorno verbose, and it'll automatically say buongiorno Maximiliano, how's your day? Pretty cool. So we've been able to combine flags, options, and arguments to create a really robust Hello World app. I'm not going to be making a lot of money on the App Store from this, but it's a good example, hopefully, that teaches you how Swift Argument Parser is really robust. So that's a really good example, but I want to go into an even more complex example of something I've built recently, which is an app I call Sappi. I wanted to build a system information command line tool similar to what I get when I log into my Raspberry Pi. So you could say this is actually an ARM app, which is pretty cool because it runs on my Raspberry Pi. And it uses Swift to display system information. So like, CPU usage, memory usage, and things like that. But then I want to be able to display command line parameters to like really change the way that information is displayed. So for instance, I could say I want the information all in percents, in the case of like CPU usage and memory and disk, or I could say I just want a raw ratio of whatever form of measurement that specific device is measured in. And so here is how that Sappi command works. We have info types, so we can specify different info types. We have verbose, but I really want to talk about this ratio format, which is another example of an option. In this case, we use a default. So depending on the system information, it'll either display it as a percent or as a percent of total for disk information, depending on, like I said, the actual, if it's a disk or CPU or whatever it wants to show. And then for our ratio format, again, we just say the raw value is string, and then we say expressible by argument, and it'll automatically parse that out for the application. So let's talk about taking command of subcommands. So in this case, we're going to add a subcommand to this Sappi app. So a subcommand, if you're familiar with it, you've used this before. So Git has subcommands for commit or init. Swift has subcommands for like build, test, and run, but also has subcommands under package for init or generate Xcode project. So we're going to create a couple of subcommands under Sappi. So we have, we're going to create one for print, and we're going to create one for export. And print is essentially going to do what it already does, but export is going to offer an export format. So you can export it as a JSON file or as a CSV, whatever you want to export that system information. So here's our Sappi command. It, again, implements parsable command, but what we're going to do is we're going to group these properties into a parsable arguments. So now we've grouped all these properties under a parsable arguments. And what that'll do is that'll allow us to reuse this in print and export, because print and export will both take the same essential parameters. And then as far as Sappi command, we're going to convert that over to a print command. We're going to specify a print command name with command configuration, and then copy over that Sappi options as the options. So those arguments will be parsed in print just as it was with the Sappi command. Next, we have our export command, which is going to be using the same arguments as well. And then we're going to add a new argument for format or export format in this case. And then for Sappi command, we're just going to say the command name, which in this case is Sappi. We're going to provide what subcommands we're going to use. In this case, print command and export command. And then we're providing a default subcommand as well. So now we could run Sappi because it has a default command for print. But we could also run Sappi print, and it'll do the same thing. So you probably saw under command configuration something called a abstract. And what this does is it allows us to give help to users of our command line tool in order to see what is going on. So as far as Sappi command, we had an abstract that says that Sappi does prints and exports system information in this case. We could also provide abstracts under our subcommands as well. We say the export command exports system information in any format. Print command prints system information out to the console. And as well as the under our property wrappers, they also take a help parameter as well. So in this case, info type, we say this is the set of information that you want to see, whether CPU or memory, etc. What format we want our value types under our ratio format. And then verbose, we can say output all values available. And this is going to be really helpful to our user. This is obviously how the command works without with just running the command. But if we were to run the command without any abstracts, without any help, and we say -h, we'll get this, which is not super helpful to our user as far as what they need to do to really like play around and be a power user of your command line tool. So by providing abstracts and help under the properties, we can actually provide help to the user. So now when they run Sappi-H, it'll actually print and export. It'll actually print out this abstract and this helpful information to our user so they know what's going on. Again, with print and our subcommands, we could do the same thing where we're actually adding helpful information. I almost think of it like a user interface for the user of your command line tool. So that way they can actually know what they can do and what is available to them as far as arguments, options, and flags. So now you've built a command line tool using Swift Package Manager or Xcode. How do you deliver this to your users? So one thing, especially if you're doing, this is publicly available, you can use Homebrew, which is pretty popular. Homebrew has a few complications though, because you're going to need to create a makefile of some sort, or some way you can build the application using Homebrew. And then you need to create a separate repo for the Homebrew formula. And then you got to make sure you publish each release and update your Homebrew formula every single time. So here's an example of a makefile. With our makefile, we just say we have our install, which builds, and all of that does is create the directory to make sure that it makes sure that it creates the directory and copies the installation over, and then make sure to build it in release mode and disable sandbox using the Swift command. The formula actually a bit more complicated. So here's what the formula looks like. We had attached some metadata for the description. We have a home page for our application in case they want to look up some documentation. And then, by the way, near the bottom, we make sure that they have Xcode so they can build your application. But it's really, to me, the URL to your actual source code and the SHA code that is going to be really difficult when it comes to Homebrew, because you're going to have to update that every single time. So that's where something like Mint comes in. Speaking of, Janos was already name dropped earlier when it came to Xcode Gem with Stefano's talk, but here's another project he's built, which is Mint. And what makes Mint really nice is it can install a command line tool pretty easily just by specifying the owner/repo name from GitHub. So you can install Mint through Homebrew, thankfully, and then use Mint install. And then, like I said, the repo owner name and then the repo name. It'll automatically install your application on whoever user's machine. So I really like Mint, and that's probably the way I would go, rather than going through the chore of actually creating a homebrew formula and just letting people know that they can install it via Mint. But if you wanted to go the homebrew route, you can do that as well. Before we go, I wanted to give a few tips. When specifically, I want to talk about running your command in development. So you're going to be using Xcode to develop your command line tool, obviously. What you're going to want to do is you could specify arguments by editing the schema. So if you're not already familiar with that, just simply go to Edit Schema in your Xcode menu and then go to Run, and you can specify arguments there. There are going to be times where you actually want to run your command in an actual terminal, but you want to debug it. So what you're going to want to do is you can then go to the Info tab under Run in your schema, and under Launch, just say waiting for application to be launched. And then what you could do is run the application by either doing Swift Run, or you could do Swift Run, especially if you need to supply arguments. You're going to have to supply your command name. So you just do Swift Run, command name, and then whatever arguments you want to pass within the terminal. And that will make it easier for you to debug, but also see what it's actually like to using your app. I almost say it's like a command line simulator in a lot of ways, because people aren't going to run this app within Xcode. They're going to run it in the terminal. So this is a good way to actually test out the app and the experience of running your command line tool. Vincent kind of touched on this, and I want to touch on this here today when it comes to command line tools. Dealing with asynchronous processes. You're going to do this. You're going to have to make some sort of network call in your command line tool. So it's helpful to know, like, how do you deal with that case? Because you have code like this where you're waiting on something. What are you supposed to do in Run, which expects a synchronous process to be done? So the way I've gone about doing it, and I've talked to a few people, is by using the core foundation run loop to do this. So what you could do is set up a result that you know is going to be set somewhere. That's why I have it set up as implicit optional here rather than an optional. And then when that is done, you can stop your run loop. And then outside of that, you want to start the run loop after you start that process. So you could be making your network call, run the run loop, and then stop the run loop when the async call is completed and your result is set. And then just simply do try result.get to either throw the error that is a result of that async call, or to just finish printing or doing whatever you want to do with that result. So that is async calls. Here's some sample code you can use. If you want to just use a parsable async command, I set up my own little protocol, run async, that returns an error. And then from there, you can just easily run. You can just automatically extend or use this protocol, and then it'll automatically deal with any asynchronous processes with a callback, as opposed to just waiting for something to be done. So I want to cover what we talked about today. We talked about why command line parsing is difficult and why you might not want to do it yourself. We talked about what tools are out there, specifically Common Dot and Console Kit, depending on if you're doing server-side stuff as well. We talked about why Swift Argument Parser is great and really takes advantage of Swift as a language, and making your command line tool Swifty in a lot of ways. I touched on how to get started with the Swift Package Manager and building a command line tool using the Swift Package Manager. We talked about adding a dependency to your Swift package and how you'd go about adding specifically Swift Argument Parser to your package. And then we talked about creating our first parsable command, which is the base protocol for creating a command line tool. We talked about arguments, flags, and optionals, as well as how to do subcommands, which we've seen a lot in Git and Swift as well, which Swift also uses Swift Argument Parser. We talked about giving help, that is by giving abstracts and helps through the different property wrappers for arguments, options, and flags. And then we talked about delivering your new tool, whether that's through Homebrew or by supporting Mint as well. Before we go, we should probably talk about what other things you might want to look at next. validation, and errors. So there's a lot you can do with dealing with errors in different ways and how you throw those errors and giving users feedback based on like if there's a parsing mistake or whether some process couldn't be complete. So definitely check that out. Unit testing. You could do unit testing. You can manually parse strings through the Swift argument parser in your unit test rather than actually running a command. So you'll definitely want to check that out. Something to think about is Linux support. It's actually not that hard to do. And if you've set up some sort of CI through GitHub Actions or Travis CI, I have an article on this, by the way, if you're interested. You can actually test this easily with Linux using any of those CI tools that are available. You could also do some advanced parsing. Like I said, similar to Codable, you can parse command lines in a similar way. So you'll definitely want to check that out as well. We talked about help, but we didn't talk about completion scripts. You can actually set up completion scripts for Bash or Fish or ZSH. So you'll want to check that out as well. And we talked about asynchronous tasks. One thing to look at is how you want to batch some of these tasks together. I have a talk about this as well in an article that I will also let you know about. But I also recommend using something like PromiseKit if you're going to be having a lot of asynchronous tasks at the same time that you'll want to follow, and then using that parsable async command in order to kind of cleanly follow the Swift argument parser methodology. So I'll talk about a few projects that I've done recently using Swift argument parser that hopefully gives you some inspiration about what you can build using Swift argument parser. We already talked about HeySap. That's just a really simple sample command line tool that's available to you to look at, and it has all the source code that we talked about today. Sappi as well is available to you for gathering system information of your Mac or Linux machine or your Raspberry Pi. I've built a whole library for dealing with asset catalogs and developing complex app icon sets. And there's a command line tool for this. So if you want to create an app catalog really quickly, you can take a look at AcidLib that uses Swift argument parser as well. I have a tool in GitHub as well for setting up a Swift package with continuous integration called Eggseed that uses Swift argument parser and also has a lot of complex PromiseKit code in there. If you want to take a look at how I manage that, take a look at Eggseed. And then Speculate, which is my command line tool app for building app icons out of SVG files, is also available. And I'm slowly moving that over from just a manually parsed mess of command line tool over to Swift argument parser. So that should be updated pretty soon as well. And then if you're interested in using CloudKit with your command line tool, you can actually do that now. I have a library available called MistKit, which actually plugs into CloudKit using a command line tool. And you could also use it with a server-side app as well. So if you actually are interested in using CloudKit and building a command line tool, that is available to you as well. Source code is available on a demo as far as how to do that using Swift argument parser as well. If you want to read more about the Swift argument parser, take a look at the official repo located on GitHub, as well as the announcement by Nate Cook, the lead developer on Swift argument parser, who helped me a little bit with this presentation today, which really gives you the rundown of how to use it and why to use it and why it's great. Erica Sadoun, who has been on my podcast, has written a few great articles on Swift argument parser, which you can check out, whether that's dealing with asynchronous processes or installing via Mint. So links right there. And then Erica was on my podcast and she talked about Swift argument parser, and there's a link there to episode 52 with a link in the show notes to episode 51 as well. Thank you so much for giving me the opportunity to speak, and I'll take questions if there are any.